Hi everyone. Thanks for inviting me today. My name is Arshdeep Singh. I'm a researcher in Ear for Sound project, Center for Vision, Speech, and Signal Processing, and Sustainability Fellow in Institute of Sustainability within the University of Surrey. So today I'm going to present on AI and sustainability, our people-centered approach, how within the University of Surrey we are approaching AI to design technology and how we are solving the sustainability issues of AI and in general application of AI. So my presentation include background on how I get exposed to data and AI. Then I will explain uh, for layman or from machine learning researcher perspective what data and AI mean. We'll showcase some AI demonstrations that we developed at Surrey and or in general. I will move to two important questions which needs to be considered while doing AI research. So that leads to next discussion or slides presentation, which are on people-centric approach and limitation of. In the end, I will summarize my presentation. Yeah. Okay, so let me give a brief background of myself. So in 2013, I started my master's from NITTT Chandigarh, and we got the opportunity to work with Professor S.S. Pranay. He was the first person he introduced me artificial intelligence and artificial neural network, and from there I got interest in this particular field. And then my thesis work was from CSIR Research Chandigarh with Dr. Apana, where I worked on designing my first AI model with MATLAB and image dataset to categorize different class of images for security border surveillance purposes. Then I moved to IIT Mandi for my PhD from this beautiful campus situated in Himalayan region, and I had the opportunity to work with Dr. Padwana Varaj and Dr. Anna Sir, and I have learned many things about machine learning, AI basics from Dr. Renu and Dr. A.D. Dilip. So in PhD, I work in audio data where the task was given an audio recording to tell from which environment this audio is coming. Let me just showcase how this audio data sounds like. So given this sound, you need to tell, which environment is this sound is coming from. And I learned many things from a Menace lab, which is a lab of young researchers at that point of time. So I got quite familiar with this audio data and AI from in my PhD as a backbone for my research. So then I moved to University of Surrey in UK within the Ear for Sound project for my postdoctorate, where I'm a research fellow and working with Professor Mark D. Plumley. And here I got opportunity to work more on audio data and AI from people-centric and sustainability perspective to understand the limitations and more applications of AI used for sustainability. So yeah. So what actually the data is? Uh, so if we see in our surrounding, we have abundance of information. We can hear, we can listen, and there is something in the form of text and the numerical form. So all these things which can make some sense, which can give some information is data. It can be in the form of images, videos, audio recordings, vibrations, and in the form of text reports or anything that is transformed into numerical number and can be understood by computers. So that constitute a data which can be used to build this automatically learning models, which is AI. So let's see what AI is. Let's see what this artificial intelligence is. So we have a brain, a complex brain structure from newborn to adult. So we learn many things through examples, and we have a billions of neurons which got activated at different point of time for different underlying tasks. And with this brain structure of many neurons, where we learn from examples from time and experience, artificial intelligence is something creating the similar neural network structure, which is called artificial neural network, and which can mimic some task that human does. For example, we can easily discriminate between dog and cat. So artificial neural network, can be creating a network and showing these examples of dog and cat, and then building a system that could automatically detect these dog and cat in future. And this AI is, we can say, is something, creating machines that can think, listen, see, and operate somehow like human does. So AI is data hungry, and it needs data to learn any underlying task. Fortunately, we have abundance of data. So let's see, what we can do with AI and data. So we can, use this abundance of data to make sense of surrounding with AI, and the applications like security, um, home surveillance, assistive living, to monitor human activity in medical health care, for environmental monitoring in bioacoustics, or traffic monitoring, or in general the media, video, audio search. So it can be possible with this AI to solve this kind of practical applications. Let's see some of the demos, what AI can do with data is. So here I will show a demonstration where we dwelt in Surrey. So this AI model, takes audios from the surrounding with microphone, and it tells what activity is happening in the surrounding. So here, if you see here this picture on the right side, so here you can see the top few predictions from the model, and with this prediction probabilities or confidence. So AI model can hear the surrounding and tell what's happening in the surrounding. Let me just showcase this demonstration to you. Yep.
Okay, no more. No more. Okay.
Horse.
A high school girl's been murdered. Mr. Harrison's daughter is missing. And
So I see, this AI thing, can detect diverse set of events, sound events, for example, from gunshot. That's really important from security perspective. Sorry, or the music, or the baby cry, to monitor these kids at home if you are away working from home. And some of the yep. And some of the other application of AI, let's say, we are given this kind of audio recording. Let me play this one.
Random number. So I've just made two methods. Haven't really created them, but this is how I'm going to deal with them. And before.
So this example contains speech and background engine noise sound, engine sound. So while recording the data set, this data set might be sensitive to private information. Right? So the task is to separate out different sound sources within this recording, and we can give a human query, let's say, the engine sound of a vehicle. So if you are interested in only this kind of sound, so we can give it to the AI model. Then what it can do is so it can separate out, it can remove speech sound which might be sensitive from the privacy perspective. Yeah, let me play this how the output is being generated from a model sounds like. So this is how a model can be used from this application as well. Yeah. And from the generative AI perspective, so one can generate set of data with this AI models. Let's given a text, it can generate sound. A model can generate sound or ambience. Let's see some examples. So here the text query is two space shuttles are fighting in the space. Or other text queries like a man is speaking in different kind of rooms, so can generate ambience as well. So AI can be used to generate data set as well. And other applications, for example in image classification, typically in iPhones, you can see the photo tagging, or this iPhone automatically do the people face recognition and cluster those images in one folder, right? So we have seen some example of AI and its use cases. So AI is really doing, and we are really happy to deploy AI everywhere. But there are very important questions to ask at this point when AI is being used in many applications. Uh, in Surrey, we are asking two very important questions. The first question is, whether AI is being used for society, for people or end users, whether it really solves the need of the people. For example, the engineering approach to use AI as a tool to improve performance, whether it's used blindly without understanding the impact of AI or its usefulness. So to answer this, there's a this people-centered approach that we are opting in Surrey. And the second question is, are we all overestimating the potential of AI and only talking what AI can do best for us, rather than exploring the limitations, challenges, or other side of AI? This is where I'm going to explain the limitation of AI in next few slides as well. So let's see how these two questions are handled at Surrey, and how we are contributing towards this other side of AI. So the idea of this people-centered approach within Surrey started when Surrey launched this new institute of people-centered AI in 2021, where the approach of using AI was seen completely in a different angle by putting people at the heart of AI. And in this approach, the focus was to use starting point of AI, people rather than technology. And this approach drives the research and enables design of AI technology and systems from the ethical, responsible, and inclusive way. And within Surrey Institute of this PAI, the focus areas are trustworthy and responsible AI, AI for education, media and entertainment, AI for health and well-being, and then the human AI interaction, AI for society in general, and also looking AI from the perspective of sustainability, to use AI for sustainable applications, and also looking other side of AI which targets the impact limitations and responsible trustworthiness of AI in general. So let me give you one example. So this part people-centered approach. So I do work in a for Sound project, which is uh, where the motive is to use sound data and AI to improve home, workplace, well-being, and also design AI sound tools which can be used for creative sectors, or in general focus on sound and AI stuff to solve problems within city, home, and workplaces. So within this project, there is a diverse team which is led by Mark Plumbley. He's a professor in signal processing. Myself is in machine learning expert or experienced person, and then we have design researchers with social science and humanity background. Then we have research engineer alongside PhD students, and project manager as well. So you see here, if you are using AI for some application, then we have a team which have diverse skills, right? So what that bring to on the table is different perspective to solve the underlying problem. It's not that we are designing a model just to improve performance or anything. So first step that is coming within this project is from the design researcher side, which uh, who interact with users to understand the problem and limitations, or what users want from AI technology, and then things are moved to machine learning researchers uh, who are responsible for designing the solutions for the underlying problem identified from the discussions design researchers or our team have with users. So let's see how this within this project we follow this approach. So approach within our project. So we are following a participatory approach which start from the people. So here users and stakeholders, they drive the research agenda rather than the engineers or experts. So what happened in the first stage of the project is uh, so if you see, if you're aware of this double diamond, so it is about discover, define, develop, and deliver to solve any engineering problem. So first of all, design researchers or in general project people, so they come up with a general problem, right? Then within the general problem, let's say we want to use sound to explore anything that is still not identified. So that general problem is posed with sound, and then we invite people, participants, to come along and share their perspective on this general problem. So once the discussion happened with participants, then and the next stage is to define the insights from this participation, this divergent discussion. So from there we come up with specific problem, right? So it might be using AI for sound to solve a certain problem, and then we do ideation on top of that. Once ideation is built, then we build prototypes, concepts. Then again we reach the people, that how do they feel if this ideation, this research solution and problem makes sense for them. So this is an iterative process where people are coming together and we're building collective understanding, supporting quality listening as well, and implementing cogeneration of knowledge, which foster the cross pollination of ideas, right? So this is how this participatory approach works within this people-centered AI approach, where users and stakeholders, they are telling the research agenda to solve, and they set the agenda for machine learning researchers to target the certain problems they are facing, or they feel from their own perspective, rather than a certain technology which is already designed and then it is reaching to the people houses for their recommendation. Well, within participatory approach, so we are opting this World Cafe method to foster discussions across people, and it can be in a virtual mode or in-person mode. And what this World Cafe approach is, so it's this cafe style discussion where assume that we are going to have some coffee in some cafeteria. There are many tables, people are sitting on one table, they are discussing some ideas, and then once they have concluded some ideas, then they are sharing the ideas with all tables, whole room within the cafe, and then uh, once that understanding is built, and in the end a global discussion happen within the room across people to refine the understanding of ideas, right? So this is a World Cafe approach, and so we organize one of the World Cafe in a virtual manner during COVID time, where the sessions lasted for 2.5 hours. We started with introduction of the general problem, and then there were three 20 minutes breakout room sessions where people are divided into breakout rooms within Zoom, within Zoom platform. And people discussed locally, and then they come up with their summary of their table within this 10 minutes mini harvest sessions, which happened after each discussion. And then in the end there was a global discussion for 20 minutes that refined the whole idea. So this way, this discussions or this World Cafe approach is helping towards this participatory method, right? So within so within so within this World Cafe, this virtual World Cafe discussions, we asked uh, uh, these three questions in each breakout room session. The general question, it was general question. So first question was, describe the sounds you hear in your locality. It can be natural, mechanical, or a human sound source. And what did you find pleasant, annoying about these sounds? And then the second question was, describe your ideal listening experience in the space. Why, what would you add, remove, amplify, or quieten to make it more ideal? And why are these changes important for you, right? And then asking an imaginary technology to create your ideal listening experience in the place. So these questions are discussed within the breakout rooms, and what we conclude after discussion of this in-person virtual cafe is that so natural sounds, they can be very pleasant, for example bird sound, and then they were mechanical sounds, they can be very annoying, tapping noise, it can be horrible, chaotic. And then atmospheric human sounds can be pleasant if children are playing sports. Some sounds may not be pleasant and may be irritating, and telephone sound, for example, telephone sound depends on the purpose. So AI tech for controlling and personalizing sounds could improve this urban living. So it can be used for blocking, masking the unwanted sound, people shouting, and it can allow pleasant, practical sound through, you know. This is how this idea from general problem we come up with this conclusion that using sound, it can be related to well-being in the home and workplace. So from our previous this discussions, we moved to next World Cafe, where task was uh, to have a discussion on envisioning future homes of well-being. Uh, so here we ask questions like, how can technology support future homes for well-being? What should future homes for well-being look like, and what are the challenges to build this? So from the discussion, what came out is that so the technology must be adaptable, easy to use, and it should make life better. And It's important to use of sensors based on the personal need and seasonal changes. It should be adaptive, and technology should be meant for every stage of life. For example, it should be compatible with the young adults and old people as well. And from this discussion of how should future homes for well-living look like, so which home should be quieter, they should integrate technology with latest technology, and should be interactive and controllable, and they should be activity monitoring framework. For example, if patients are there at home, so one can monitor the activity, and they should be intelligent system using AI to learn things within homes, like seasonal changes, etc. And from the challenges, the concern was the privacy is one of the top concern, and then there should be a balance of privacy and tech benefits. So it should not be that while achieving privacy we will lose the capability of technology, and the use of data and its transparency again is again one of the concern was there in our discussion. So next we move to our next this World Cup discussion, where our specific focus was on designing AI for home well-being. So here the group people for discussion was from research from experts from AI background, from universities, researchers, and from industry. And we asked questions in this World Cafe. For example, how can AI support home well-being for human flourishing? What are the key barriers to designing AI for well-being, and how do we overcome these barriers and challenges? So from this question, for how can AI support home well-being? So discussion was around so using AI for food quality insurance and reducing the waste within kitchen, and then AI should improve the love and belonging rather than uh, more personalizing creating more personalizing spaces, like nowadays we have mobile phones, so mostly people remain busy with their own phone and do not talk to each other. So AI should this improve this love and belonging rather than creating its adverse effect. um, and then AI can be used to improve house architectures as well. Then psychological needs should improve basic need as well, and should handle the data within homes and use data in some or other way, and it should also contribute to energy, so to reduce energy consumption within homes. And from the barrier perspective of designing AI, so it's important to discuss this decision makers who who how the policies will be make or upgraded for using AI within homes, and then infrastructure, how we incorporate this AI technology within old infrastructure. So are we spending more money on new infrastructure, or we can use the existing infrastructures to embed the AI technology? And then from the future perspective, so to understand the impact of AI if technology is used fully within AI, so it's important to discuss with community, with the wider experts, to understand better the usage or utility of AI. So this is how we embed AI with this people-centered approach by putting people at the heart of AI. So after getting those discussions or summarization of concepts coming from different discussions, we come up with concepts, and then these concepts are design concepts where some prototypes might we build before finalizing the technology. Then again we reach to the users to understand how do they feel now with this technological solution. So this is an iterative process which is still going on. So we have seen how we are opting this people-centered approach with this World Cafe and participatory method. Yeah. So now the second question that initially I discussed is to understand whether we are overestimating the potential of AI and are missing the exploration of other side of AI. So let's see, what other side of AI looks like. Uh, so typically, the AI models which are used to solve complex problems, they require uh, large amount of memory, large number of parameters to solve nonlinear complex problems. Just an example is ChatGPT, where the accuracy of this GPT model improves as the number of parameters increases. Like it has around 150 billion parameters, which takes huge amount of memory, so which is really costly. And if we see the performance of AI models versus computations, so again there's a high correlation that heavy computations they lead to better performance. But again, this computations, if I talk about these computations of a model, they lead to use more resources, so which lead to make the AI model as resource hungry. They need resources to run, and because they require large memory, a model size might have billions of millions of parameters, which demands memory, and memory is really expensive, which makes this AI models as energy inefficient. So this other side of AI is very crucial to understand. And if we see the impact of this energy inefficiency of AI models or requirement large resources on environment, that is huge. For instance, Google AlphaGo Zero, so this system, gaming system, which have beaten human experts. It's a air waste framework. It generates 96 tons of CO2, which is equivalent to 1,000 hours of air travel and 23 American home carbon footprint, when this AI model is trained for 40 days. And a simple example, typically in our labs we use NVIDIA GPUs. So if you train that model for, let's say, 48 hours, so it can generate CO2, which is equivalent to driving a car for 13 miles. So this impact is really huge. And this Google AlphaGo, it takes these many resources as well. For example, to train this, you need these many CPUs, around 2,300 GPUs, which is equivalent to $3,000 electricity bill per game. So that makes life really sad from the AI perspective. And from the perspective of using AI on edge devices, for example, on your wearable smart watches or multiple sensors working together in future, so uh, which have a low resource requirement, so large AI models, they are not practical to deploy. This is again a challenge in deploying those well trained, well performing AI models. Just to better understand what we try is, so we just develop a prototype, a edge device, personalized edge device, which can send surrounding sound and uses Raspberry Pi. So let's see, just let me show you this just demo how it works. Yeah. Oh, I can't there. Yeah. So this demonstration is a personalized device, which can send notification to your phone while detecting what's happening in the surrounding. So if you use this device, let's say for 10 minutes, and if you try to analyze temperature of the device, it raises like 5 degree within 10-14 minutes, and it causes in reducing the latency, or sorry, in in reducing the speed of inference. So this is just very tiny example, which showcase that, if we have, let's say, large AI models or edge devices, and we embed things on these edge devices, so temperature is a big issue, so that causes slowdown. And this is crucial from the temperature, environmental temperature, which is raising since last 5 years of the globe, with which approaching towards +1 degree Celsius change since last 5 years. So, and this change is really bad for our environment. It takes vast amount of heat to warm all the oceans, atmospheres, and the land masses by that much. So this contribution, or limitations of AI models, which requires this sufficient resources to train or generate significant amount of heat. It can also significantly contribute to our environment, this temperature rise, right? And especially data centers, or the AI, which is in next 4 5 years everybody gonna trendy towards using that, and with lots of resource usage, lots of GPU. So this thing is really important to consider, uh, of this energy inefficiency, and the resource usage by AI models. And this leads to explore the other side of AI, which is the sustainable AI, because AI is resource hungry, energy inefficient, and the big AI models, they consume lots of resources. So it's important to consider these parameters while using AI in your research. So what we are doing is, we are trying to, it's my own project, so we are trying to come up with efficient algorithm architectures or AI models, um, um, by reducing the computation memory requirement, and hence contributing somehow to the environment, right? And within University of Surrey, so we have this AI sustainability program, where across the universities, so people are targeting towards sustainable goals and using AI for sustainability, for example, AI for security, clean energy, or climate change. And the whole approach is embedded to the people-centered approach. Also, this environmental centric approach is coming together to solve this uh, this people-centric applications from the environmental centric perspective as well. And it's important to see this AI and sustainability from both perspective. For example, AI can be used for applications, for sustainable applications, AI for net zero, AI for food system, AI for climate change. But at the same time, it's important to consider the sustainability issues of AI models as well, which is this energy consumption, and this trustworthiness, its explainability, um, and its data efficiency, right? So this program is led by Dr. Eric Sprendio, and I'm leading one of the core areas on data and model efficiency within the sustainability of AI program. And also we are also, other thing that is important from the perspective of this AI sustainability is the awareness, and reaching out to the whole world or wider society. So we are organizing, we have organized the workshop with industrial people, with researchers, and from the academic people to get more understanding of this topic, right? Example, contributing or participating or organize special sessions in various reputed workshops is a key to aware people and get together, right? So in summary, what I would say is, so we have abundance of data around us, and with variable sensors, data is not scarce for most of the applications. So we can use AI, because it's data hungry, to leverage the abundance of data to solve the underlying task with the existing computing resources. And it's important to have an idea of this people-centric approach, the problem we are targeting with AI, and whether it's sustainable or not. And also we should be focusing on reproducibility demonstrations to showcase or motivate people, how, or to make people better understand how things work in this AI world. It's a black box, but in one sense, if you have understanding of basic subjects, then it's no longer a black box. It's more or less a gray box, I would say. And then reaching out the wider audience is also important for networking and making aware and getting ideas from the experts or the users. So these are, I think, some of the key practices for sustainability as well when we are using data and AI. Yeah, so I would like to stop here. Thank you very much for inviting me here. And this is my email ID and this is LinkedIn ID. If you have any questions, discussions, please feel free to ping me, and I'm happy to take any questions. Thank you very much.